Energy data sharing. PRIMRE's been doing this for several years now, and we've had a good response. So we'll start off with an overview of past workshops, and we'll dive into the theme of this workshop. We'll have a presentation from Australia on their data systems, and then we'll go into a little bit of an overview of what's new in the PRIMRE world, with a focus on analytics and data and use. And then continue that thread with a presentation from the Marine Energy Data Exchange. And then we'll dive into some breakout groups and hopefully have some really interesting discussions. And let's jump into the overview of past workshops. The first international workshop, we discussed the value of data sharing and the barriers to data sharing. That was a really popular topic. A lot of people struggled with different barriers, from not just technical barriers, obviously, but organizational, financial, cultural barriers. And we got strong consensus on the value of reconvening the group to discuss data sharing opportunities and progress the second year, which we did. We focused on different levels of data sharing in 2022, standardization opportunities. We featured short updates on PRIMRE, Marine data, and rescore. That takes us to our third workshop in 2023. Discussion focused on PRIMRE and interoperability and the potential for connecting disparate data sets. And we discussed geospatial data sharing and potential expansions of PRIMRE's Marine Energy Atlas. We got a lot of useful feedback from that one. Thank you all for that. And the fourth international workshop last year, we focused on the evolution of sharing science, fair and FAR data principles. We'll get into that a little bit more later in this one, if you're not familiar with those concepts, and how those features updated various things on PRIMRE and Marine Energy Data Exchange. So let's get into the theme for this workshop. Today, we're going to be talking about use of marine energy data systems and portals. How do you track analytics for these sites? How are you measuring success? What data products are being used by researchers and others, and which ones aren't? How can we improve upon these products and make them more valuable to the researcher? And also, how can we track the impact that they're having more effectively beyond, typical Google analytics? So that's the overall theme and the questions for today. And with that, I will turn it over to Louise for a presentation on Australia's data products. Did Louise make the call?
Yes,
yes,
sorry.
There. Do you want to go ahead and share your screen?
Is that okay? Yep.
Yeah.
Yep, absolutely.
I just got to, apologies, I thought I had this one ready to go.
Oh, no worries.
I just got to
I
get
blow
the
through
right
intros a lot faster than some people.
Yeah, you did.
So may have snuck up on
you. Okay, does that, so does that look about right?
Just coming up.
Okay, awesome.
Louise, there's a couple of big rectangles in gray on your slides. Do other people see that?
Yeah, just two.
Yeah, there's two. Oh, there.
Oh, that's the Zoom menu being masked out, I think, or something else that's above the slides being masked out.
I think I've gotten, did the rectangles go away?
They're just up
They're
at
up to the top, so I think you're
not
good
terrible.
to go.
I don't know.
Yeah, that's okay.
Yeah, sorry, apologies. I don't know how to get rid of them. Yeah, it is. I think it's just the meeting. So what I'm going to be sharing today is the project that we led through the Blue Economy CRC in Australia about how we are looking at using data for the emerging offshore energy industry in Australia. So there were a number of co-authors on this work, myself, Brennan Bush, Caroline Hart, and Peter Walsh from a number of different organisations. So for those who aren't familiar with the Blue Economy CRC in Australia, it's actually got 44 different partners. And of those 44 partners, we had 6 different partners that were part of this project. So BMT, which is where I'm from, Griffith University, Ocean Pixel, the University of Western Australia, and University of Tasmania. As you can see from this slide, there were a number of people involved in this project. So the Blue Economy CRC is all about underpinning the growth of the blue economy in Australia. There are 43 partners, 43, 44, 10-year life. We're about halfway through now. 9 countries participate. It goes across research, industry and government. There were 5 research programs. So it's looking at offshore engineering and technology, seafood and marine products, the offshore renewable energy systems, which we'll be focusing on today, environment and ecosystems and sustainable offshore development. There in the research centre, there have been more than 30 projects that have finished. There are over 30 projects currently being undertaken, and there are multiple future projects in the pipeline. So you can imagine that means over 10 years lifespan, a lot of data. So we had this, I always like to start with this slide. This is all about the data everywhere and not a bite to think. We often think about all the data that we collect. It's really exciting to collect this data. We get very engaged in these data. We really want to do something about it, but where on earth do we start? So what we were looking at here is when we take all the data that's collected, you're looking at yottabytes worth of data. But really when it comes down to decision making, it's really a yes or no decision, go, no go decision. And it's just that one byte. So how do we get that from the collection of the data? How do we curate it to the data that we actually want to use, analyze it, make those derived data products, and then learn from that, and then make those decisions, and continuously go up and down this pyramid as we're making those decisions and refine what we're actually needing. So we had 4 main objectives to this project. That was to design the scalable data infrastructure framework that would support evidence-based decision-making for the Blue Economy CRC. It needed to be capable of capturing, storing, analysing and visualising data that was generated by the Blue Economy CRC research projects. It also had to connect through a whole series of APIs to the federation of data, so that's sourced from research, industry and government. And it's interesting in your introduction, you talked about those challenges of being able to get data from different sources. We also wanted to make sure we had a simple, intuitive, easy to use access portals. As we all know, you can have a great data, but if you don't access that, it's very difficult to actually become useful. You need to be robust, scalable and sustainable. The idea is this framework needed to last beyond the duration of the 10-year CRC. So what could we achieve? Now that challenge, what we set out to do a couple of years ago, seemed quite a large challenge, and of course it was. So what we went in terms of what we could achieve in the end was accelerating the approval process for offshore energy development and offshore aquaculture developments, the reduced uncertainty and understanding in those feasibility studies, the transparency, trust and social license, which we find in Australia is one of the hardest things to overcome, one of the barriers to development, data sovereignty and making sure that data is protected, and then increased production efficiency. So that increased production efficiency can be the production of offshore energy or production of seafood, depending on your industry. So starting with the ability to capture, store, analyze and visualize data, we looked at the different characterizations of data, all the way from the function of the data, whether it's a repository, whether it's a product, is the analytics of those data, or it's a presentation to the public. The types of data that we characterize as well was indicated data or experimental data. A lot of the data that gets selected may not be useful in this moment, but needs to find a home as it goes through its process. The location of where those data might be stored could be hosted in a particular set of hardware within an institution. It could be part of a federated data system, or it could be mixed. And we had to make sure that we weren't just looking at one, we needed that diversity of location. Then the hardest challenge, as I said, that we had to go through was how do we work through the classification of open and sensitive data? And you'll see a little bit more about that as we go through. So this is the workflow diagram that we use as the basis of the workshops that we took in terms of the design of the framework. So we use this to sort of have a look at what we wanted to achieve. So you'd be all very familiar with a diagram like this, where it's taking the data from where it's sourced from, and we had multiple different sources, as I said, from biological, physical, biogeochemical, all the way through cultural, legal, and economic. A series of modelling and analytics. We weren't looking at the modelling and analytics, but we needed to be able to incorporate that into our workflow diagram. The derived data products, whether it's a large language model, model output, a GIS map, marine spatial planning tools, or performance metrics. And then it was all about presenting those data products so that it could then be transferred into knowledge. Again, that knowledge was about research, industry, government, and community, and we had to hit all of those targets. Then it was about, once that knowledge had been gained, how do we transfer that knowledge all the way to its end point, which is giving those insights and making those data useful. The second objective was about having those APIs to connect to a federation of data. And so this is how we looked at this here. Again, our biggest challenge was the open and sensitive data. Here's just some examples on the left and the right, the types of data that we were looking at. On the left, you'll see a whole heap of data repositories that are open. And then on the right, you see a lot of data, particularly from our First Nations people and our industry, financial or personal data, that needs to have some level of security on that. So we were looking at a system that's interoperable. It has a series of standards. You can have that fair access, the security and sustainability access. And again, coming back to the three main core components of where our data needed to be both sourced from and also delivered to was industry, government, and research. We went and put together a mock-up for the type of prototype we were looking to develop in this. So you can see on this screen, it's nice and visual. It's got lots of different buttons you can click. There's a whole heap of communities you can work through, from the people themselves, the research projects, how do you plan a project, and then an operational data dashboard all the way through to a library that you can go in and access your data. Now we're looking at the scalable part of the objectives there. So this is as I said, one of the biggest challenges we had is we looked at the current state of play in Australia. Current state of play being you can have either your data store for open data, which goes through the open data API services. But on the left-hand side, you've got that sensitive data system, and this is siloed very much. And you can see that by the brick wall we've drawn with that orange line. You've got modelling and analytics platforms also on the side of the sensitive data system that doesn't have that interoperable system with the data, the open data. We can start moving that to the right, but then once your modelling and analytics platforms become open, it's very difficult to keep those data secure. And you can start working with trusted identity services to provide that access. So then we started looking at how do we have the open data on the right going through some of these existing platforms. We've got, I won't go through all of them in the limited time, but please feel free to reach out to me after this presentation and I can talk you through a little bit more in detail about those platforms that we have in Australia. And then the sensitive data, which is locked up on the left. And so this was the solution that we came through. And again, just to emphasize that this is a federated integrated platforms in an ideal world. So it doesn't actually exist yet, but what we're looking for in this design is using the IDSA to have a data system so that those rules of exchange or those rules of engagement have been established, the sensitive data is protected, and you can have communication between the different locked systems where the sensitive data is shared, and the only data that gets through those locked systems is the data the particular person and your identity has access to. So on the right-hand side, there's a lot of, again, those open sources. If you're not familiar with them, please feel free to sort of reach out and talk about them later. But we have Australian Open Data Network, we've got CMAP Australia, AusCBAT, the Bureau of Meteorology, all of those are open data sources. And so we went through and looked at a few user stories because we needed to test how this would potentially, or socialize the idea of how this could work. So we had a number of different people. We had Joe from the Blue Sky University who was developing a wind farm site selection tool. We had Jane from Aqua Blue Fish Farm who was looking at forecast risk assessment tools. Janice from Blue Wind Farm who was looking at operational planning for scheduled maintenance. And then we had Jack from the Blue Stake EPA, and they were looking at a screening EIA tool for development approvals processes. And finally, we had Jessie from Blue Bank, who was looking for a sustainable assessment tool to invest in the Blue Wind Aquaculture Company. So we had quite a few user stories, but if I just go through one, which was Joe, who was that student from Blue Sky University, I should say none of these organisations actually exist in Australia. We were using them as use cases to socialise the idea of this integrated platform. So Joe was working for a university, but was designing a nature-positive foundation structures for the Blue Wind Farm. Joe needed to provide data to Jessie, and Jessie was a sustainable investment manager. Jessie was working for the Blue Bank, and they needed to determine whether this design that Joe was proposing met the ESG criteria to include in the Blue Bank's investment portfolio. So because of this interoperable enabled blue economy infrastructure, Joe was able to provide the insight for decision making from that sensitive data provided by Janice, who was material engineer from Blue Wind Farm, Jack, who was from the Blue State EPA for the cumulative impact, and Jane, who was working for Aqua Blue Fisheries and the long-term effort forecast for fisheries in that same area. Okay, so I'm not sure how I went for time there, but I don't know if there's time for questions, but again, as I said, feel free to reach out to me after this session to ask questions.
That was great,
Thanks.
Louise. Thank you. And I think there's some time for questions, don't you, guys?
Yeah, definitely.
Okay.
Yeah, thank you for that presentation. That was wonderful, especially at, I assume, 1 a.m. your time.
Correct.
It's great to, oh, please go ahead.
No, I was just going to say I'm actually in Canberra this week. I'm actually hail from Perth, so normally it would be a little bit earlier, but I'm in Canberra for the National Marine Science Commission presenting a white paper on modelling and quantitative science at that next level from the data to the modelling. So we're all gathering in Canberra to discuss.
Well, thanks again. It's wonderful to hear what you all have been up to. I definitely appreciate you staying up late to show us off. I also really appreciate the user-centric design and how much thought was put into the user stories and putting this whole thing together. So I will be quiet and see if there's any questions. I may kick one off then, since I'm not seeing anything in chat or any hands raised. But I'd love it if you could dig in a little bit more to the challenges of essentially combining the open data with the restricted access data. What was the largest challenge you encountered in trying to do that?
Two things. One, for the restricted data, there are it's a cultural change to be able to start thinking about your data as a common good or a value that can be shared, especially when you've spent a lot of money collecting it. At the moment in Australia, we don't have offshore wind. It's an emerging industry, and it's a really good example there that people are spending millions of dollars in their feasibility and planning stages to get approvals, and they're reluctant then to share that with their competitors. So that's just one example. There are other examples, for example, First Nations data, and those data are and always will be something that cannot be shared in an open platform. So it's both cultural reasons, but other reasons as well, commercial reasons. And so once to be able to develop that trust, so developing a product or a system that people can actually trust that they upload their data or they become part of that community, that the only people who will have access to that is the people who have the security or permissions to use that, but also then starting to look at what parts of those data can then be shared, so you don't necessarily have to give up everything, especially anything that's commercially sensitive. You can give that derived or product data, and a community of impact assessment is one of those very key components there. So you can provide what is that your development is going to be in terms of the pressures on the marine environment, and then you can look at your neighbours doing the same. So the derived data that goes through to the EPA and potentially all the way through the public is not going to be coming back and haunting you for your contribution or misinformation, which at the moment, unfortunately, is very big all over the world, but also in Australia, that we have at the moment data being misused for that reason too.
Yeah, excellent. We are seeing many of the same things, especially the cultural shift of my data is my baby, and I don't want anyone else to see it. It's a real struggle for sure.
And one solution we've been putting forward, which is something we adopted, I think, from the European system, was, and I'm going to get this wrong, persistent identifiers, PIDs. So once you've got that on your data, it means that sort of sovereignty or provenance is then established. So this is particularly for those working in the research space, that it comes back and you get that credit for the development of that knowledge as well. So back when I first started in academia, you pretty much only had your journal publications as a PDF. And once you can start then they started, providing the data catalogs, and then that really, really helped as well. So sorry, Andrea, you've got a question.
Oh yeah, Louise, really great. Thank you. I was just wondering, I know you've done all this planning. Where are you in developing the system? What are some of the things you found, including sort of the barriers to, because clearly I think this user centric idea is absolutely wonderful and should appeal across funding sources, but how is that actually going?
That's the last bit of your question is actually hitting the nail on the head. It's the funding sources. So in Australia, like everywhere in the world, the funding is not there. So we've first of all, it took a lot longer, probably 2 to 3 times the period, just to get the framework or the idea, the conception together. And in that time, so the timing is really difficult, especially when you're working in a very collaborative space and you want to be inclusive. And it was really important for us to be inclusive because the CRC has those industry and government and research partners. So where we're stuck really now is getting that funding. So we have the idea, we have the concept, we have a lot of people who want to be involved in this, and this is from industry as well as government and research, because if you can come on and play in this collaborative space, then you'll be able to, really maximize the benefit of the data collected and that multiplication factor. So that's where we are at the moment. We're putting a funding application in. So we've got 2 sort of ways in which we're going. One, we're using a commercial product that BMT has developed about 15 years ago for the offshore oil and gas industry. So it's well used in terms of looking at collecting and managing data and making quick decisions when the hurricanes are coming as to what you do with your platforms, all those sorts of things, really big data. Because it's a commercial product, it can go relatively quick to develop. At the same time, parallel, we are looking at those open data sources and try to bring, it's like that bridge in the middle. So rather than wait until the funding can come for a complete solution, we're looking at sort of funding from this end here, which is that commercial product, which is well developed and quite mature, through to the open data, which is also very mature and quite well developed, but it's just that sort of section where it can go through between those interoperable. And we do see the IDSA as part of that solution. If everyone can come on board and go, yes, I want to be part of that, then it's going to be a lot easier to bring that back. So yeah, funding is really what's holding us back at the moment. But if we can just keep building bridge by bridge, brick by brick, that bridge, that's where we see we'll get that solution, but it's not going to be easy.
Thank you. That's great. I know there's a lot of people involved in these data systems worldwide where funding and especially the models, how do you either, because I get asked quite often, how do you commercialize or how do you make money off your data? And of course, the best answer is don't. Just get someone to pay for it. But we all know we live in the real world. So yeah, great.
And that's where industry does help in that way, as long as you can then share it. And one of the things we talk about a lot is that sort of like, rising tide floats all boats. So if you sort of look at that and try and have that cultural change, that data itself shared is going to rise your boats, and then you can have your commercial sensitivity on what's going through in terms of the knowledge coming from that. That's what really helps to sort of start bringing people to the table. But yeah, as you said, it's a challenge.
Thank you.
I think that's a nice segue into the rest of this workshop, and ties neatly into our theme of how do we demonstrate impact for these data repositories, not just for our individual data solutions, but also to help support others that are starting up and seeking funding. With that, I will share my screen and jump into a brief overview of PRIMRE. And following that, we'll have a presentation from Marine Data Exchange. Okay, let me know when you can see my screen.
Yep, it's up.
It's good.
Excellent. So I suspect for many of you, this may be a review, but for some of you, you may be new to the PRIMRE ecosystem. I'll briefly go over it and try and focus on what's changed in the last couple of years. The portal and repository of information on marine renewable energy, or PRIMRE, provides access to marine energy data, information, and resources. We have a 7 Knowledge Hub series of different tools. And the question we get all the time is, why are there 7 and not just 1? And the answer is that each of these really caters to a different data source, different data type, and a different audience. And so this goes back to what Louise was talking about with user-centric design. We are trying to deliver data and information to different groups of people in ways that are tailored to them and their needs. And a lot of times those are mutually exclusive. So starting off at the top, we have the Marine Hydrokinetic Data Repository. This is hosting data from the US Department of Energy's Water Power Technology Office and all of their funded projects. We do also have some other international data sets in there as well, but it has been primarily populated by US DOE funded research and development activities. And TETHIS hosts documents on environmental effects from across the marine energy industry. This is open to the entire world. There's a team of people at Pacific Northwest National Lab that goes out and seeks different journal articles, papers, white papers, et cetera, on the environmental effects of marine energy and puts them in TETHIS. Launched under the PRIMRE initiative, its sister site, TETHIS Engineering, hosts technical documents and engineering documents with the same premise, and is another valuable resource. Marine energy software is where we're hosting codes and software, not just things that have been developed in the US, but things that we think are of use to the industry. This is where you can find valuable tools like WEXSIM and MHKit. You can also find commercial products that are being widely used to see if the software you need is already out there and hopefully help you avoid reinventing the wheel, especially when it comes to common calculations and quick code snippets. Telesto is our newest platform. It's hosting testing and measurement guidance. This is where we keep international standards, and we've organized Telesto to go across the timeline of development, but really it's kind of a catch-all for best practices and guidance throughout the entire lifespan of marine energy development. And it's obviously continuing to expand at regular intervals as we learn more and more as the industry grows. Marine Energy Projects Database is a database of all known projects and devices that we're aware of. We have another team of people that are actively going out there and assessing that. We've worked with OES to bring in some of their projects data, and we try and keep that as up to date as possible. So if you know of a project that we don't have in that database that's out there, please let us know. Or if you see your project in there and want to make updates to it, you can create an account in PRIMRE and update that yourself, or you can shoot us an email at PRIMRE Help and we'd be happy to update it for you. And last but not least, we have our Marine Energy Atlas tool. It hosts GIS-based resource maps. It's our GIS data tool where we can do map-based analysis and planning and siting. So PRIMRE tries to be the one-stop search that organizes all of these. A little over half of these existed before PRIMRE in some way, shape, or form, and we tried to pull them all together into one ecosystem and make them interoperable. And that was a big part of our topic a few data workshops ago. But moving on, I'm going to talk about what's new. So we have PRIMRE has been combined with ODI. My plus is a little out of place there, sorry about that. OED is the Open Energy Data Initiative. It's an initiative that's a partnership between the National Renewable Energy Lab in the US, the Department of Energy, and 3 main cloud providers to provide universal access to big data. And that data lake is, if you're not familiar with the data lake concept, it's rather than storing data in individual repositories and downloading it to use it on your computer, we're storing it at a centralized cloud location. So there's a single access point for that data. It's really valuable for big data. We have over 68 terabytes of marine energy data in there. Some of the data sets are many tens of terabytes in a single data set, such as our high resolution Way of Hindcast data set. And it just demonstrates the need for data lakes. I see the whole industry sort of moving in this direction as the size, volume, and complexity of data just continues to increase. We just simply can't continue to download these massive data sets obviously won't fit on a laptop. You need some sort of specialized compute system. It's easier to have them in the cloud, and people can park their compute systems around it. They can create them in the cloud. They can actually connect conventional HPCs on demand to the cloud. And you can essentially camp out around the lake. And then everyone's working from the same data source, which reduces the duplication of effort, duplication of storage. And we're not spending a whole bunch of time transferring tens or hundreds of terabytes from one organization to another just to try and collaborate on a solution to a problem. Less transfer time means more research time, more productive time, and we're all working from the same data, so there's less of a chance of things getting out of sync. So we've been really focused on data lakes and as a solution to big data problems, and we're really happy to see that unfolding in the PRIMRE space. It obviously doesn't work without data standardization. I'm not going to spend a whole lot of time talking about this. Hopefully we all get the concept. We have to get all the data in the same format in order to be doing meaningful science and collaboration, and in order to avoid misunderstandings. There are a lot of trips and pitfalls that can happen with poorly formatted data, or even worse, with data that appears to be formatted well, but people are just making bad assumptions. You have a spreadsheet, column T and numbers under it, and you assume T is temperature, but maybe it's something else that starts with T. Silly example, but you get the idea. What I did want to talk about is that in the PRIMRE universe, we've recently made a change in our thinking about data standardization, and it appears to be working for the better. So we initially set out with what we were calling content models or data models, where we would have predefined data schemas for different types of data. These came in the form of Excel spreadsheets or XML schemas. More recently, we could have adapted them to JSON, et cetera. But the idea was that if you're collecting this type of data, this is the format we would like to see it in. And then if everyone did that, then all the data would be interoperable, and we could start mashing it up and creating cool innovations and insights from it and doing fantastic research. The problem is not every research team has an embedded data scientist. In fact, very few of them do. And to them, they're going to collect the data in the format they need that's the most useful for them to solve the problem at hand. And there's often not enough sight or foresight into how do I make this data useful for the rest of the world now that I'm done with my project. And a lot of times you're not even thinking about that until a data submission requirement at the end, or you are out of money because your project's over and there's just no time and resources left to do any sort of standardization to make your data more discoverable or interoperable by the rest of the world. And so we tried to flip that paradigm around, and we're stealing a bit of a strategy from the banking industry. Banking and electronic transactions have been happening for many decades, and going as far back as the early 70s in the US, the electronic transactions of money. Banks had standards, many standards, but they didn't care about settling on a single standard because ultimately they wanted the money. If somebody's going to send you money, you're not going to reject it because it's not formatted in the proper standard. You're going to reconcile that on your end. And that's what we're doing now. So our new approach to data standardization is give us your data in any format and we'll standardize it. we have the in-house data experts, we have the data scientists, and we will be more efficient with the resources on standardizing that. And so we have developed a marine energy data pipeline that is flowing data inputs of all sorts into standardized formats, and then adding them to our data lake that's connected to the marine hydrokinetic data repository. And so far, this is working better than the old system. We're seeing, it's a little early, but we're seeing good uptake and adoption. We have an example of our Packway site observation data that's now flowing through and being updated in near real time, I should say. And so you're definitely welcome to check that out. But I'd be curious to hear thoughts at the end of this on our data standardization approach, and happy to answer questions on it. Before I get to the end, though, a couple more things to highlight, tying back into the theme of this workshop. One of the other new exciting things we've launched is Ask PRIMRE. This really came rather easily because of all the fruits from other labors in the data standardization space. In order for PRIMRE to coalesce all the knowledge hubs and make them a single ecosystem and make them more approachable for users, we had them all adopt a PRIMRE metadata schema. So they were all speaking the same language. And then we flowed that into a centralized search for PRIMRE that houses metadata from all of the different knowledge hubs. So you can go to PRIMRE centralized search and you can search across all the knowledge hubs at once, which makes it very easy for users. But because all that metadata was already in machine readable format, and because we adopt FAIR and FAR data principles, which help make our machine readable data more findable, accessible, interoperable, and reproducible, and also machine readable and AI ready, it was really easy for us to then just say, hey, we've got this awesome library of metadata, and we've got all these articles in Tethys, and supporting documents in MHKDR, let's just connect them to ChatGPT and make a virtual research assistant. And so that's what we did. It's not a full chatbot. We've restrained it. It doesn't go to the internet for answers. So it's only limited to the vetted, curated information within the PRIMRE ecosystem, where it allows people to ask complex, deep questions on marine energy that span across articles and across data sets. And it also allows people to ask it to perform essentially research assistant tasks, which is why we call it our AI research assistant. You can ask PRIMRE to go read 5 articles for you and summarize them, or to analyze across various data sets and find commonalities. Tying into the theme for this workshop, we'll talk a little bit about PRIMRE analytics for tracking use. We do rely heavily on Google Analytics, and we're using wave analysis for accessibility. Accessibility is one of our success metrics. We want to make sure that our data platforms are as discoverable and accessible as possible. We're also doing a lot of engagement with blasts and social media, counting content. How many articles do we have? How many data sets do we have? How many wiki pages do we have, et cetera? But we're still finding this challenge of truly measuring our impact across this space beyond typical Google Analytics. And I'll get into that challenge in a specific detail in a moment. But I wanted to point out that when we're tracking impact, it seems like a disproportionate number of our most impactful statements are still coming from human contact. Kudos, frequent engagement with the community, conferences and webinars are still our most important channels to garner those success stories. And one example from Google Analytics is that, in this particular snapshot, we had 11,400 users over this period of time, which looks like about a year, and 71,000 views. But we may get an anecdote from a user that just one of those users and 2 of those views was an insurance underwriter who was looking to fund a new marine energy project. That's a huge win for us. We're helping new projects happen by providing the data insurance companies need to underwrite those projects and the support they need to convince investors that it's worth their time. And so it's really easy for a very impactful moment to be lost as a single blip in something like Google Analytics. And that's why we're still so heavily reliant on kudos and just one-on-one engagement with community and events like this to hear stories from you all. Another really interesting example is our network of data sharing. So we're operating primarily in the open data space. Almost everything we deal with is in open data. We do have a little bit of restricted, but we'll set that aside for the purposes of this slide. The Marine Hydrokinetic Data Repository is obviously connected to PRIMRE, but you can see it's also connected to ODI, and it ties in directly to TETHIS through our signature projects. It also, every data set within PRIMRE also ends up on Google Dataset Search, in r3data.org, science.gov, the US's data.gov, and then from all of these places it federates out to international partners, other federal agencies, et cetera. We've done this for a couple of reasons. Our goal is to disseminate the information and make it as broadly accessible as possible. We don't want all the traffic to come to us. We're trying to consolidate the ecosystem and be a one-stop shop in the interests of user convenience. But we also want users of data.gov or Google Datasets to find all the PRIMRE data, all the marine energy data too, and it should be at their fingertips. And it is. And when they hit download from any of these sites, they just get the file. If they follow the link to the data lake, they get the data lake. They don't have to know that behind the scenes, that information, that request is being routed backwards through the network. And so through this federated network, we're seeing over 1 million downloads, and only a small percentage of them are actually coming from our core sites. That's about 10%. The other 90% are coming from the other members of the federated network. There's two important things about this. One, this ties into what we were talking earlier about a culture shift. This is a real selling point for our attempts to shift that culture. We like to say that publishing your information on PRIMRE is like publishing in a dozen sites at once, a dozen journals at once. And we have the data to support that, which is awesome. The second point is, how do we have the data to support that? For those of you that are more tech savvy may have caught on already. If I'm a user going to one of these other sites, I'm not on PRIMRE. Therefore, I'm not showing up in Google Analytics for PRIMRE. So how are we tracking that? Well, we built an advanced analytics engine that's capturing these analytics from our network of partners at the server level. It's not limited to browser-based use. And that has a couple other advantages too, as in that it lends support for artificial intelligence and machine learning and LLMs and other use cases. And so if somebody's accessing our data programmatically through the data lake, if they're writing Python scripts and downloading a whole swath of data from PRIMRE, we're capturing analytics on that. And that makes it really important because we're able to demonstrate that impact outside of the web space, in the true programmatic research space and also in the AI ML space. So I would love to hear from you all on what you're doing in this space to capture metrics, and also any questions you may have for us. And I'll pause there. Any questions? Okay, well, we can continue the conversation in the breakout rooms for sure.
Hello.
Hello.
I would like to ask if this is mainly for America or if it is also including European information.
Each of the PRIMRE knowledge hubs has a slightly different scope. Most of them, all of them have some sort of international information. Some of them have more European information than others. The Marine Hydrokinetic Data Repository is, I would say, 95% US. But looking into some of the other PRIMRE knowledge hubs, and I'll jump back to my description slide here for a moment. TETHIS and TETHIS Engineering are global, so they're trying to capture information from as many countries as possible. Marine Energy Software and Telesto have no restrictions. We have international standards in Telesto, but we have, being US funded, there is a US bias. We grab the easy stuff first and then branch out to international, if that makes sense.
Thank you, and congratulations. I am making a database of projects, but just an Excel file. This is much better.
Thank you. Louise.
Yes, my question was about the analytics. First of all, this is just really awesome, the way you're doing this. I think that the incentive to share is just a really awesome idea to kind of have it where you're providing the standardization service. But this one here about the analytics, this is something that you've obviously got access to, and others have got access to. Google would have their own metrics. If you've uploaded data to any of these systems or a model or a tool, does that flow back to the sort of the provenance or the original supplier as well, so that they can get those analytics to justify sharing more?
Absolutely. So the way this works, and I apologize, I used a techie term and probably glossed over it, but this is a federated network. And so only the metadata is being passed around. So the actual data for us the data for PRIMRE lives on PRIMRE, the data for the MHKDR lives on the MHKDR. And we're sharing the metadata with this network of partners. And so if you go to a site like data.gov, it looks like the data is right there. And if a user clicks download, they just get the file. But what's happening is behind the scenes, data.gov is saying, I'm going to request this file from the MHKDR and deliver it to the user. And so the data is not duplicated. And because of that federation, the requests always come to us, and that's how we can track them through the analytics engine. They're not coming through a web browser though. They're coming direct to the server through like a server to server connection. So we just had to develop our own sort of analytics system at the server level. Does that answer your question? Yeah, it's pretty interesting. We've looked into, like, there are other famous, we're having conversations with Zenodo right now, for example. Zenodo isn't federating at the metadata level. They're more of a duplicate the file over there. And so that doesn't work for our analytics tracking, although that they're a big presence in the research data space. So we want to get them involved too, but we need them to do a little work on their end too before they'll fit our model. Any other questions? Great questions. Thanks. Okay. Well, with that, I will turn it over to Marine Data Exchange. Do we have anyone from?
That is me. Yes, I will.
Right,
Yes, Harry.
Share my screen.
Thanks, Harry.
With me. Can you hear me all right?
Yep.
Perfect. Okay. Thank you for that, John. That was a fantastic slideshow, and there's a lot of sort of overlaps and a lot of really impressive stuff that you guys are doing, which we should definitely take on board at the Marine Data Exchange. So thank you. Hello, everyone. I am joining from a very warm closet in London, or feels like a closet, but it is a meeting room in an office, I'm told, as the Marine Data Advisor from the Crown Estate. So I've been the Marine Data Advisor for just under 2 years now at the Crown Estate, and I'm sort of representing the Marine Data Exchange, which is our open access data portal for offshore energy. So if we get into it, I want to first spend a bit of an introduction for both the Crown Estate and the Marine Data Exchange, so I'm not throwing around words or terminologies that people haven't heard before. We did present last year, so there may be some overlap here, but there's a sort of a new topic and a new theme throughout this, so hopefully there's value in it for everybody. So the Crown Estate is a really unique company and an organisation. It was established by the Crown Estate Act in 1961, and essentially what its main business unit, or it's the business unit that I'm involved in, is the marine business unit. So we have essentially what is a retail company or a property company, but we own the seabed and the coastal area, and we manage the rights to the seabed, as well as multiple estates within London and in the countryside as well around the UK. So what that looks like is for the marine team is that a very crucial and important role, especially in the wake of, or in the presence of the transition to net zero, is being responsible for managing the seabed in England, Wales, and Northern Ireland. So this goes to 12 nautical miles, but also understanding and being responsible for leasing rights further afield. So the main thing that the marine team do is offshore wind energy. So that's crucial as sort of world leaders in offshore wind. The UK has a really important role, and therefore so does the Crown Estate. So where the Marine Data Exchange fits into this, the Marine Data Exchange, the MD, which I might refer to it as, is a a database, as simple as that. It was created in 2013 for the sole purpose of really sharing and broadening the impact of offshore survey data. So when I say offshore survey data, it's survey data collected through the lifespan of offshore projects in England, Wales, Northern Ireland, and Scotland now as well, from feasibility of an offshore development to decommissioning of an offshore development. And as I say, mainly just due to the industry dominating, this tends to be offshore wind, but it also includes stuff like aggregates, wave energy, tidal energy. So it's broad brush as well there. So as I say, it was designed primarily to ensure the reuse of this data. Quite often in offshore wind, especially, the data gets collected at great cost and effort, but then once it's done for the environmental monitoring or whatever purpose it was collected for, it often gets stored away in the archive. And this is fine. It's just supported an offshore wind farm being built, which is absolutely great, but it gets locked away, and academics or future industry or planners trying to use this data can't access it. Fortunately, the Crown Estate back in 2001 put a data clause within leases for the seabed. So just like you might lease a flat or a storefront, we lease the seabed, and we put a data clause within this within these leases, which basically say that the developer, so that the tenant, if we're continuing that, is required to deliver offshore survey data. So this is a contractual obligation, and this is something which is different from other databases you'll see, which sort of take data on at requests. With the Crown Estate, our customers, what I'll call offshore wind developers, are legally obliged to provide this data, which really gives us a really unique and beneficial position to acquire the data. So not only is it for sort of internal decision making, helping us manage and plan the seabed better, but we feed it into many academics. So I'm supporting a few PhD projects, internal academic projects, where we have the Offshore Wind Evidence and Change Programme, which is understanding the impacts of offshore wind and how we can use the data on the Marine Data Exchange, again, just to make sure our decision making and our planning to 2050 and in the future is done with the best data and evidence in mind. So it's really crucial that we're using this and not collecting data for the sake of data, but collecting it so we can use it internally and provide it to the right stakeholders externally. So that's a bit about the Marine Data Exchange. Feel free to butt in. I can't see anybody, so if you have a hands up, please butt in and say. I don't mind answering questions as we go or waiting to the end. So this is a bit of a snapshot of what we have. So you can see top left, the majority of it is wind data or wind industry data. This varies. So we've got bird surveys, ornithological surveys, benthic surveys, but we've also got stuff like wind resource data and geophysical surveys, which sort of tell us the makeup of the seabed as well as the atmosphere and everything in between. We've also got aggregates there, wave and tidal, and then research. So research is a really important thing, making sure that, as I say, we're not storing that data, but we're disseminating really valuable research that is done internally and across our partner organizations. So at the minute, there's about 3,000 series. So series is what we refer to as an individual survey, 400 terabytes of data, and around 7,600 users. So the numbers are going up in all aspects. So the data holding is absolutely skyrocketed due to our capability of taking on a lot of this data, but also just as John mentioned, the data is only getting more high resolution, more complex and large in that aspect. So as you can see here, a continued increase in the number of surveys that get delivered as there's an uptick in the number of surveys being performed with offshore developments, and the majority of these splitting between these themes here. So a theme is essentially the type of data there, and that sort of highlights a bit of the diversity in what we store. So as I say, you've got stuff like the metocean and the primary ones here you can see are the geophysical ones. So this, as I say, is the nature of the seabed. So what we do with the data, this again, hopefully will shape some of the conversations I'm going to have about impact and analytics as well. So the data comes in. It is my role as the data advisor to support industry and our customers to submit that data and comply with their data obligations. we put it through a quality assurance process. So we use the MEDIN data standards. If you haven't heard of MEDIN, MEDIN are the Marine Environmental Data Information Network, and they create a set of guidelines and standards that we base our quality assurance process off. So they include mandatory components for each of those data themes, as I said, that needs to be included for this data to be as findable, accessible, interoperable, and reusable as possible to, again, push that fairness to our users. So then ultimately, once it's passed its sort of commercial sensitivity period, which is sometimes quite long with these development projects, as you can imagine, we then get it published. So this is freely published. It's not controlled or withheld at all. Once we get approval to publish, it is free to access. And it's then used by various things. So it goes off and is used by industry. We use it internally, as I say, in research and evidence projects. So I sit within the data and insights team. So in my strand, we've got the data team, but we're all constantly thinking what we can do from an insights and evidence perspective to make maximum use of the data that we're in the fortunate enough position to sort of be able to collate. And you've got things there. So that's the Offshore Wind Evidence and Change Programme, as I mentioned, PhD support, internal and external research. So again, really pushing that, finding what programs and research is going on in the country and seeing where we can feed in to drive broadened impact of this data. The whole of seabed program is something we run internally at the Crown Estate, which is basically a comprehensive evidence base of all the data that is available across England, Wales, Northern Ireland, which helps us put together and basically plan the seabed out to 2050 in different scenarios. So we can understand what the seabed will look like in 2050 based on this data, based on what we prioritize and based on the scenarios we run. So for example, we might prioritize fisheries, and therefore we'll run a scenario and see if fisheries get the priority, wind farms might have to take a step back in certain areas, and we'll find areas of opportunity for wind farms. If we prioritize money, then it'll be different outputs, and understanding actually through those various scenarios, what's the most realistic one, what's going to benefit the majority of our stakeholders without sacrificing the need to support nature recovery, but also the transition to net zero, which is at the end of the day is what a lot of the Crown Estate targets are based off. So to get to sort of the crux of this, in how we internally track metrics, understanding our audience and measures impact, there's various things, and what I've done is split it in between the front end, so the front end data, and the back end, which may make sense to some people, but if not, just please do raise a hand. So we use Google Analytics heavily, as well as John was mentioning. And this is a lot where the sort of overlap comes from. So Google Analytics, we look at and we sort of investigate on a quarterly basis to see where our data is used, when in the annual cycle it's being used, and how our users interact and navigate with our data. So this is really useful engagement analytics. It understands what events we're going to, what engagement we're pushing, and how that lines up and syncs with certain increases or decreases with our engagement from the front end. But it also is just really helpful in understanding what markets globally we're reaching and where we can actually be doing more in terms of feeding our engagement to make sure that people aren't just coming from one area, but they're coming from LinkedIn as well as website, as well as just coming to it from a natural Google search, because that's really important, that we don't want our full audience to come from LinkedIn. We want to make sure that the Marine Data Exchange is pointed to and it's findable without knowing about it previously. This is where I sort of get onto what John was saying, and that kudos point is that is huge for us. So not controlling our data or not having a lock on our data means anybody can access it, and anybody can use it for whatever reason. And that's exactly what it's for. So as much as it can be seen as a bit of a negative because we don't know what it's being used for, that is the sole purpose of the Marine Data Exchange, is that there is no barriers or blockers to using it. So therefore, we need to sort of find and understand other ways to understand or to reveal who's using our data and what those big wins are. And there's sort of two here that I've got. So ad hoc requests, as you sort of mentioned. So we have an inbox where people get in touch quite frequently at requests, and we sort of engage with them, generally have a meeting with them to understand what they're using the data for, and if there's anything else we can help with to allow them to get maximum value of the marine data exchange. So again, industry and academic use cases makes really sound justification for continued funding and also revealing that impact. What we've recently done is, as you can sort of tell by the 400 terabytes of data, we've put a lot of this into cold storage. So we've only put stuff that's over 100 gigabytes into cold storage. So this is the geophysical data, which is raw data, which is lesser used. So we've done engagement from analytics and found which of our series are not used as much, have less traction, and we've basically put them into cold storage. That's a really recent input, but what that has revealed is actually now it's a manual trigger for me to provide that data for someone when it requests. So there may be a few days, whereas when it was in hot storage, to explain that technical term, or not so technical term, but when it was in hot storage, somebody could download it at a click of a button. Now it's in cold storage. We have sort of made them financial savings because it's not as expensive, but also it does now take a few days for me to get back to them and provide them with that data. But an unintended consequence of that has been really beneficial, is we're understanding how often people are acquiring this data, where they're coming from, so what organization, if it's industry, if it's academic, and we're just seeing a lot more requests for this data come through, which is again really helpful in understanding our audience, and something we didn't have previously. So this is something we'll get onto at the end of this slides, is what we can be doing better, because we don't really want to be relying on these ad hoc requests or these cold storage requests to be understanding our audience. Because when somebody comes to us and say, why are we putting so much resource into this, and you're putting so much time into acquiring this data, can you tell me a little bit about what benefit, how it's benefiting the industry? I want to be able to have a comprehensive list of use cases and benefits and quantifications of how this is being used. And to that end, we've sort of put together something back in 2023, which was a bit of a first stab at this. And it was the Marine Data Exchange Impact Report. And if you're curious, I can send this out, but it's available online as well if you Google that. And essentially what this includes was trying to basically do research and understand what is our impact, what can we refer to if we come under scrutiny and someone asks what is the value of it. And we did this through various things. So we quantified, and we've also got a valuation report which came after this. We quantified the value of the Marine Data Exchange data holding. So how much would it cost to recollect all this data? So this is an interesting spin on value. Of course, that's sort of different from value, but it's the recollection value, and that was over £1 billion. Now, the value of that data is obviously slightly different, but it's a helpful proxy when having these conversations. And another thing that we include in these reports, there was some major use cases as well of what the data is fed into. And again, that just sort of goes on that merit kudos thing where we've worked with them actively. So we know what this data is feeding into, and it less revolves around the ad hoc use that we don't know. So moving on to back end and how we use the metrics in sort of the confidential side of things to help our audience. So we do quarterly reviews, and we basically extract data internally to understand how much data we're acquiring each quarter, how much data we're publishing each quarter, and the data holding as well. We also do quality assurance data analytics. So this is something I've been picking up recently, is understanding all 3,000 surveys that are on the Marine Data Exchange go through quality assurance. We need to be extracting data from that to understand what is our rate of failure, what are the pain points, so what are the common errors that we're getting with the data, and the common queries raised. And the whole purpose of both of these sort of analytical methods is to expose gaps and problem areas, and then we can ultimately fix them. And that's something we're doing at the minute. I'm currently going through a sort of triage process to try and get AI involved. So it's really good to see you doing that as well, John, but a few years ahead, it seems, to use AI in this quality assurance process as the basis to fill the gaps that have been identified from these analytics. And although, as I say, this is back end, so these quarterly reviews and the quality assurance is back end, the ultimate goal is to improve the data holding and the data availability on the Marine Data Exchange. So the quicker we can get the data published, the reduction in time between data collection, data uploading, quality assurance, and then ultimately publish means there's less lack of data and there's more availability of that data for the users. So really understanding that how we can use this data, because it's all held, we can use SQL, but unless we actually use it, we won't do anything with it, and therefore understanding how best to use it. And that's again why I'm attending, to see how other people in the industry is using data for our management systems and seeing if there's anything we could be doing better to make the most out of what is in reality a wealth of data. So I've sort of touched upon this, but driving improvement really not only improves the availability of data, but the quality of data. So if we get our quality assurance system more sort of cohesive and we manage to implement AI and get the basis of this on our analytics, then we'll improve the quality of data as a result. The confidence in data, trust in data, and then the financial savings. And that financial savings isn't just an internal benefit, but it basically opens up budget to sort of feed into other things within the Marine Data Exchange and can plug gaps elsewhere. Live feedback and iteration. So we're also sort of on that AI point currently thinking of other ways we can implement AI, and there's sort of use cases that we've developed and started developing on the back end again, which sort of revolve around automatically generating series summaries. So where you've got PDFs, we'll extract the information from PDFs and create an abstract, if you will. And likewise, in a separate use case, we're having a bit of a chatbot where you can have a search, pick series and reports of interest, and then import them into a chatbot internally. And what we're trying to do there, again, to understand sort of the metrics and the success of this, is have live feedback. So when we implement this ultimately on the front end, having a system where users can either sort of give a rating or give some feedback to, again, give that constant iterative improvements in our systems, and making sure that we're getting that or opening up more doors for the users to come into and give us that feedback where previously they haven't existed, and we've relied on these ad hoc nature of the kudos that was mentioned. This again touched on that qualitative metrics, so it's really important to utilize our stakeholders for these feedback, mainly, as I say, because it's not always possible to understand who's using them from the Google Analytics. So we have a steering committee. We are closely integrated with the academics, such as the PhDs we support, and we have good relationships with the universities around the United Kingdom, but also that sort of ad hoc customer feedback, as you said, at conferences and various events. We really try and get the word out. So that's, as much as this day is about talking about the metrics and what we can do quantitatively, this will always be crucial, and we always want to make sure we're putting an effort on this to make sure we're hearing, as you say, one conversation with somebody can be really powerful, and actually understanding how we can get the most from that and not relying on this. So yeah, I think that is all. One more slide. So I actually don't know how much time I had, probably gone over, but do cut me off if I have. This is the last slide. Is talking about what we could be doing. So as I say, learning today about what other people are doing, it's really helpful. But we really need to be investing in more in analytics. So using the data that we're collecting, it's there, but understanding actually what we could be doing, seeing if we could be highlighting more desirable series that have been used, if there's something more popular, and therefore if we should be pushing insights or sort of stories around that to make them more used, or if we do the other way, and if we highlight areas that aren't getting as much traction and put an extra effort into getting those out there. The next one is sort of reference tracking. So much like we were talking about with the federated system, understanding who's using this data. If we have a reference piece that people can sort of use when they're referring to a series on the Marine Data Exchange, then we can automatically track that. It's not currently in place, but it'll be really useful when academics and industry are using it, having an automatic way that they can refer to it. And then a login feature. So we have the Marine Data Exchange logins. That was developed as sort of the first iteration. It's really about bulking that out, creating new features that are open to people with a login or who decide to log in for free. Again, that will be able to provide us insights of what our users are doing in a more granular basis. And that login is not to close it off to people who don't want a free account, but it just creates extra insights for those who use it frequently. So I'll leave it there. Thank you. Hopefully I haven't put us off the agenda. But if there are any questions, feel free to ask them now or later or over the message. But yeah, thank you for the time.
Thanks, Harry. That was awesome. I really enjoy connecting during these international workshops. I learn something every time. I appreciate it. And I'm also happy to say that I think the dashboard you showed off for the Marine Energy Data Exchange with all your impact metrics, we've recently launched a new about page on PRIMRE, heavily influenced by that. So I think it's a wonderful dashboard, and it's inspired some of our recent improvements.
Great to hear. Thank you, John.
We probably have time for a quick question or two, but I want to make sure we save some time for the breakout groups as well. So yeah, any questions? While people are looking for the hand button, I'll ask one, hopefully easy one. Could you give us an example of like one of the, I guess, incentives that'll be behind that new login feature?
Yeah, so that's exactly a great question, and we're discussing sort of how we balance incentives and without penalizing those who haven't made a login. So we want it to be available, but the benefit of a login is people can start to curate their accounts on Marine Data Exchange. So save areas of interest or save sort of themes of interest. So for example, the PhD I'm supporting is a benthic student in Wales who's studying the impact of offshore wind farms on benthic ecosystems. And the incentive for her to log on would be the ability to sort of create an area of interest physically, so around Wales, for example, and highlight themes and methodologies that she's interested in. So then ultimately we can sort of create a notification system that says, oh, in your area of interest, there's been a benthic survey that's been released that has the methodology tag grab. So that's exactly what she's looking for because she's picked those keywords and those tags. And that's something we couldn't physically do unless someone gives us the sort of permission by signing up with an email and flagging those areas of interest. So that's just one example, and that's something where it's really beneficial for those using Marine Data Exchange repeatedly for larger projects. Obviously, if you're just coming at it from an interest point of view or just to find an answer to a question, it's a different sort of thing. But if you're using it for a research project, that's really a strong use case that is